Hi everyone, we are a group of students from Electronics and Communication branch of RV College of Engineering. This is our experiential learning phase 1 project presentation. This is my group, Mashmi and Shana, Shrikar M, Giridhar MB, and myself, Mrudul MJ. And our topic is Smart Irrigation System using Internet of Things. Presentation outline, introduction, detailed explanation of components used, explanation of the program, working model of RMS, SMS based irrigation controller. In conclusion, why to conserve water? Many believe that our water supply is infinite. However, our supply is quite the opposite. Only about 3% of the total water is available as fresh water. But more than 60% of this water is contained in ice caps and glaciers, making it unfit for human consumption. Clean fresh water is a limited source, which is in turn vital for a healthy body. And life without water is just miserable. One can survive without food and shelter, but not without water. Water is not only essential for drinking but also extensively used for various agricultural and industrial purposes. Like 80% of water is used for irrigation in India. One main drawback of traditional method of irrigation was wastage of water. As a solution, WaterSense labeled products are adopted. WaterSense is a program sponsored by the US Environmental Protection Agency (US EPA), designed to increase the water efficiency in the United States through the use of special label on consumer products. The goal of the program is to protect the future of US water supply. WaterSense maintains partnerships with key utility manufacturer and retail partners across United States. WaterSense is voluntary rather than a regulatory program. Some of the WaterSense labeled products are shower heads, irrigation controllers, spray sprinklers, etc.
Now begins with the introduction part. Introduction part contains the water sensing label irrigation control, like how the water sensing labels, like the sensors are depends on the different types of weather casting sensors and the moisture sensors, humidity sensor, even the temperature sensors and all. So let's start with the basic idea of water sensing, like label sensing the irrigation controls. And this type of sensors we are generally use in the gardens or lawns for the small type of irrigation system, nor and that depends on the sunlight available in the period of time and also the humidity present in the atmosphere. And depending on the sunlight present in the particular area, the irrigation property determines the how much the water should be supplied to the plant, or the based on the humidity present in the atmosphere. Depending on that, the water will be supplied to the plants. And in this type of irrigation there are two types of irrigation controllers: weather based irrigation control and soil moisture based irrigation control. As I told, the weather based irrigation control depends on the temperature and humidity and the sunlight intensities, etc. And soil moisture basically depends on the moisture content, the amount of water which is present in the soil, and the ions also. It depends on some ions also. Now I'm going to talk about the weather based irrigation controllers. Weather based irrigation controllers, that is the irrigation, the supply of water takes place by the technology of IoTs and determining the local weather reports with the sunlight intensity and humidity sensors. The how much water had to be supplied to a particular plant has been determined, and and the amount of water that should be passed to the plant is basically it comes through the IoT based sensors, and it will determines how much our water should be supplied, and it gives the complete data analysis of that. And the soil moisture irrigation controllers, it's basically that depends on the moisture content in the soil. When the soil moisture sensor is placed deep through the earth, The water content or the electricity supplied through the sensors which are passed in the intensity of electricity is collected from the collector. From that they determine the sensors, how the sensing of the moisture content will work. Like the water, how much ever the water is present in the soil, the amount of electricity supplies, like conduction takes place in the water below the soil. So that on that depending on that, the moisture content and the amount of water to be needed for the plants is determined. Next I am going to talk about the purely about the sensors. Sensors are the volumetric meters which determines the amount of water, or it determines the sensing part of the area. Like it measures the soil property and the soil moisture must be calibrated, and maybe the varying depending on the environment factors, the like temperature and electricity conductivity through the soil, so that you can determine the moisture content of that. Based on the technology, the commonly used to identify indirectly measure the volumetric water content, the frequency domain reflectometer FDR, time domain transmission, that is TDT, or a time domain reflectometer, and neutron moisture gauges, and soil resistivity and galvanic cells. These are the types of the soil moisture content sensors. First, we are going to discuss about the frequency domain reflectometer. This basically contains the oscillating circuit which is placed or embedded inside the soil, and the operating frequency will depend on the value of the soil dielectric current. It depends on the amount of the receiver takes the frequency of the passed wave. In on that technology, the moisture content will be calculated. Next, we are going to talk about the time domain reflectometer or time domain transmission. This basically the indirectly based on the collection of electric and dielectric property of the material, such as the soil and the products, and this wood, the wood which is the conductor, which is the basically the non-conductor, but that depends on the indirectly based on the and it's also depends on the snow and etc. And it basically works when the sensor is inserted in the soil. The standard waveform analysis to determine the average moisture content along the sensor will be determined from that. And the next part is the neutron moisture meter. Okay, the gauge or the meter will be both the same. Water content in the soil, where the hydrogen present, which is present in the water as hydrogen bonds are there, is effective neutron moderator. Slowly the high energy neutron from the high energy neutron and the detector sensitivity to a low energy neutron, even it is passes through that, the detection rate will be recorded between the source and the detector. The movement of the neutron will be detected, and the slower the movement of the neutron, the greater the moisture is. Next, the soil resistivity. It depends on the how much soil resists the conducting part of the current via the earth. The greater the resistant, the less is the moisture. Next, I am going to tell about the galvanic cell sensor. So the galvanic cell sensor basically depends on the two electrodes which the galvanic cell is kept inside the soil moisture, and the suitable amount of ions are attracted for the electrode, and the galvanic cell is created. The electricity is conducted to the electrode. The amount of the absorption of the ions with the rapid phase or the time given in that phase is calculated, and from that the moisture of the water moisture of the soil is calculated. Next, based on the material, the sensors are classified. So the graphene sensor is ideally the sensor which is the every atom in the graphene is exposed to its environment, allows it to sense from the changes in the surroundings of the environment, so that the surface area of the graphene is much more compared to the everything. And the next is gas sensor. This device can sense the presence and concentration of the various hazardous gases and vapors. That is, it can also sense the humidity of the temperature and the humidity of the atmosphere. Next one is metal oxide sensors. This basically detects the concentration of various types of gases by measuring the resistance change of the metal oxide due to the adsorption of the gases, and the atmospheric oxygen of the metal oxide surface is reduced by the target gases, like the by the specific gases, allowing them more to electron in the conduction band of the metal oxide material. So the electrons which are placed on the conduction band of the metal, it will from the it can be determined for the sensing part of the material is done. The next one is nano composite sensor. Nano composite sensor based on basically depends on the sensor have been developed to offer the unique potential for a varied purposes. Next one is MZine. MZine is a inorganic compound which is actually made with a two-dimensional layer, and it is very vastly used, and the two-dimensional inorganic compound is the major part of it. The inorganic components of the is used to make the sensor. Next one is metal organic framework. These are basically the crystalline porous solids composed of three-dimensional of the metal ions held in the place by the multidenated organic molecules, so that the three-dimensional view which gives the volumetric combination to the soil, and so the from this material the sensors are also made. Next one is nanoparticle. Basically the nanoparticle developing the biosensors with the improved specific and sensitivity of the detection due to their the exclusive chemical, magnetic, mechanical and optical and physical property of the nanoparticle. Next one is piezoelectric. Piezoelectric, which is the device which uses the piezoelectric effect to measure the change in the pressure and the acceleration and the temperature and the humidity of the environment. Next, the sensors are required for the majorly for the irrigation and the sensing like sensing the how much water content it is there, and it's also avoid us to minimize the water loss by uh, taking the correct data value from the temperature of the situation. And the irrigation based on the plant's water need compared to the traditional automatic systems which irrigate the predetermined fixed schedules. And the smart irrigation technology are divided into new controllers and add-on sensors, as you can see in the slide. And the climate based controllers, soil moisture sensor controllers, soil moisture sensors, rain and freeze sensors, and wind sensors. These are the basic divisions of the soil sensors. And thank you.
Now let us look into what is an IoT based smart irrigation system. The potential of such a system is enormous. We use ESP8266 node MCU module and a DHT11 sensor, which is basically a humidity and temperature sensor, to develop this system. This irrigation system aims to actively irrigate the land based on the soil's moisture content. The frequently used components are Node MCU ESP8266 module, soil moisture sensor module, water pump, relay, DHT11 sensor, and connecting wires. Starting with the Node MCU ESP8266 module, this is basically an open source platform and its hardware is designed in such a way that anybody can edit or modify it. The Node MCU kit consists of an ESP8266 Wi-Fi enabled chip which has Arduino-like analog or digital pins on its board. It supports serial communication protocols like SPI or I2C. The serial protocols, we connect it with serial devices like I2C enabled LCD display, which is supported by this module. Moving on, we have resistive soil moisture sensors. These sensors measure the resistance in the soil and therefore measure the moisture content present in the soil based on the linearity between water level and resistance. These sensors consist of two exposed probes that are inserted directly into the soil sample. So when electric current is passed from one probe to the other, it allows the sensor to measure the resistance of the soil between them. When the water content in the soil is high, it has higher electrical conductivity because water is a good conductor of electricity. Hence, a lower resistance reading is obtained, which indicates that there is high soil moisture. When the water content in the soil is low, it has poorer electrical conductivity. Hence, a higher resistance reading is obtained, which indicates that the sample has low soil moisture.
Water pump. A pump is a device that moves fluids, liquids or gases or sometimes slurries by mechanical action, typically converted from electrical energy into hydraulic energy. Pumps can be classified into three major groups according to the method they use to move the fluid: direct lift, displacement, and gravity pumps. Water pumps run on electricity generated by photovoltaic panels or the radiated thermal energy available from collected sunlight, as opposed to grid electricity or diesel run water pumps. A PV solar power pump system has three main parts: one or more solar panels, a controller, and a pump. Solar panels make up most of the system's cost, up to 80%. There are two types of solar water pumps. One is surface mounted pumps and submersible pumps. Surface mounted pumps allow easy access to the pump itself. Is one kind of electromechanical component that functions as a switch. The relay coil is energized by DC so that the contact switches can be opened or closed. A single channel 5V relay module generally includes a coil, two contacts, normally open NO and normally closed NC. What is a 5V relay? 5V relay is an automatic switch that is commonly used in automatic control circuit to control a high current using low current signal. The input voltage of relay signal ranges from 0 to 5. DHT11. DHT11 is a low-cost digital sensor for sensing temperature and humidity. This sensor can be easily interfaced with any microcontroller such as Arduino, Raspberry Pi, etc. to measure humidity and temperature instantaneously. For measuring temperature, this sensor uses a negative temperature coefficient thermistor, which causes a decrease in its resistance value with increase in temperature. To get a larger resistance value, even for the smallest change in temperature, this sensor is usually made up of semiconductors.
Now let's take a look at the circuit diagram of a simple smart irrigation system. The diagram given here was designed using Tinkercad, which is an online website where you can interface, if you don't have an Arduino available with you. So now, in order to be able to do this, first and foremost, we require something called a GSM module. So a GSM module is interfaced with the Arduino to send and receive messages. A GSM module is basically a GSM modem. And GSM modems generally have technical specifications. So they need to be quad band based. They require a voltage of 9 to 12, and a power supply. They need a switching regulator based power supply. And the features would be they consume low power, and they're equipped with audio channels as well. So now here the board that we are using here is the Arduino Uno board, and this is a microcontroller board, and this is considered to be one of the cheapest and easiest microcontrollers to interface. So the Arduino Uno has 14 digital input output pins and 6 analog pins. So now let's try to interface the soil moisture sensor and the GSM module with Arduino. So first step is connect the moisture sensor analog pin to the analog pin 1 of Arduino. Now connect the VCC and ground of the sensor to the 5 volt and ground of Arduino. Next step is insert a SIM card in the module. Now you need to connect the GSM module with the power supply. We're using module of 12 volts. If you have a module of 5 volts, you can directly power it with Arduino's 5 volt. So connect the 12 volt source as shown in the circuit diagram. Now connect the ground pin of module with the ground of Arduino. Then connect the ST pin of module with the digital pin of 9 of the Arduino and SR pin of the module with digital pin of 10 of Arduino. We've also connected an LCD to display the sensed moisture level. So connect the LCD as shown in the circuit diagram. Also connect a pot to manipulate the contractions of LCD. Here in this case we don't have a pump, given the features haven't been added yet. We're using a motor. Then connect and relay using the relay driven diagram. After that, you'll have to gather all your components, the GSM module, the connecting wires, your transistor, LCD display, all the sensors, everything, and make these connections accordingly. So basically this having a circuit diagram essentially helps you in getting a rough idea of what connections you're about to make in real life. So that helps you get a lot more prepared. So this covers the basic outline of your circuit diagram. Okay, so now let's look at the programming involved in a smart irrigation system. So in order to program a smart irrigation system, we need to interface the ESP8266 node MCU module, the DHT sensor, and an external analog output. And in order to do that, we use the DHT11 sensor library, and the sensor library is connected to using a USB cable to the pump. So now starting with the necessary library, first we have to include the DHT library. So we use the function #include dht.h. Then we'll be interfacing them using Wi-Fi. So we'll have to call that as well. Since we are using ThingSpeak server, the API key is necessary in order to communicate with the server. And here you'll be giving a unique API key in order to access your file. And the next step is to write the Wi-Fi credentials such as SSID and the password. So obviously you have to enter your Wi-Fi name and then you have to give a password to that. After that, the first step would be defining your DHT sensor pin where the DHT is connected, and then you have to choose the type of DHT. And the moisture sensor output is connected to the pin A0 of ESP8266, and the motor pin is connected to D0 of node MCU. We will be using mil_is function to send the data after every defined interval of time. Here it's defined as 10 seconds. The delay is avoided since it stops the program for a defined delay where microcontroller cannot do other tasks. Set motor pin as output and turn off the motor initially. Then you'll have to start the DHT11 sensor reading. And then the important part here is pin mode, motor pin, output. So that basically defines and it assigns the value of high and low to the pin, and accordingly which the motor will react. So now you have to try connecting to the Wi-Fi, giving a password, and once the Wi-Fi is connected, you can move on to the next step, and it will print whether the Wi-Fi is connected or not, and until it does get connected, it will keep printing it. And then you have to define the time of starting the program and save it in a variable in order to compare it with the actual time that it has taken. So then you'll obviously have to read the temperature and humidity data and save them into variables and store that in the ThingSpeak cloud.
If the DHT is connected and the ESP8266 is able to take the readings, then proceed to the next step or return to the previous step and check again. So once you do that, you can read the moisture reading from the sensor and you can start printing your values. And if the moisture reading is in between the set values, there's a predefined input given by the user or the farmer. So if the value is lying in between that range, the pump will remain switched off. But if it goes beyond or below the required moisture level, the pump will get switched on. So as you can see that's what the code's been given here: motor pin comma high, motor pin comma high. So that will turn on the motor, and then if it's less than 56, and here we've defined the interval as 50 to 56. So if it's less than 56, it'll get turned off. So now after every 10 seconds, the send ThingSpeak function will send the moisture, temperature and humidity data to the ThingSpeak server, and the farmer or the user can access all that data from the ThingSpeak cloud. And here again, they will be using string functions here. So basically the string function allows us to print the data, right? So once the system is connected to the server, and if all the values end up becoming true, then we prepare a string for moisture, temperature and humidity readings, and those strings are sent to the ThingSpeak server. So finally, once the data is sent to the ThingSpeak server, you have client.print function, which contains the API key, the server address, and the string which was prepared in the previous step.
Now that we have looked into the construction and working of each of the component and the programming part of the project, let's put it all together to a working model. This model aims to initiate irrigation based on the soil moisture content of the soil sample. The materials required are an Arduino Uno, resistive soil moisture sensor, soil moisture sensor probe, relay, motor, battery, soil sample, and jumper cables. The basic principle behind the model is that water is a good conductor of electricity and electrical conductivity is inversely proportional to resistance. Thus, when the soil moisture content is high, the resistance is low, due to which no irrigation is required, and vice versa. The procedure is as follows. First, the Arduino Uno, relay, soil moisture sensor, probe are connected using jumper cables. Now that we have finished with the procedure, let's look into what we actually observe. When current is passed through the soil moisture sensor probe, a resistance is developed between the probes. The resistance value tells us about the moisture content present in the soil sample. When the moisture content is below the measurement level set by the owner, irrigation is initiated. Basically, the red light on the relay indicates that the soil has enough moisture content and the pumping of water needs to be stopped. The green light on the relay indicates that the soil doesn't have enough moisture content and the irrigation needs to be initiated.
Conclusion of this PPT is that, as we all know, the water content, the water is not available to the many villages. Even nowadays there is a very lack of drinking fresh water nowadays. So the conserving the water by the smart irrigation technology is being determined from this PPT, and we can also conserve by the different sectors by conserving water in agricultural sector based on the smart irrigation technology, based on the sensing and IoT based irrigation, where the amount of water which is utilized for the irrigation purpose is low and the efficient way of water utilization by the plants is very high. So the best method for the use of the water and reduce the wastage of the water by supplying the amount over supplying the water, and to the unnecessary irrigation like putting the water if the moisture of the root even it's high and wasting the water from that, and the moisture analysis and the parameters like weather condition and soil moisture level, it can be judged, and the water content of the water supply can be determined from that. The sensor technology helps develop the irrigation controller where the irrigation can be initiated and when it is required, and it can be stopped when the moisture content is high. And these are the major conclusions from this PPT. And the water, conserve the water as much as you can. The references for the making of this PPT are here. Like we collected the information from these sites.